Yes, we just had a little bit of difficulty pointing the Faulkes Telescope there today. We're going to try a different object for a minute, see if we have any luck finding that. And if I search, click on there, we're going to look for the Spindle Galaxy. No, we're not. We're going to look for the GC 5189. We type the object name in there. This is the planetary spiral, and for some reason it's not giving me. I have a feeling I'm going to have to type in RA and deck. We seem to be having a few issues today. I'm going to type in the coordinates of what I'm actually looking for. So here we go. Planetary spiral. I've checked these earlier, thankfully. The planetary spiral should be 133330. Sometimes we get little problems with the Faulkes Telescope like this, and it doesn't work quite the way you expect. These figures are easily enough to check. This is called the planetary spiral, and the image is stellar. And if I click on continue, if I just double check those coordinates, 133330 minus 655900, yep, hopefully that would be the correct location of this object in space, and we will be moving to the telescope. Here we go, we're moving the telescope, and we should be having a webcam image there, very, very grainy. We should just see the telescope moving against some of the fixed background of stars in space. I can just make out the telescope moving there. It is very, very grainy image, but that enormous telescope we saw is moving around in space. It's just tilting around there, hopefully to line up on the constellation of Musca, the Fly, in the southern hemisphere. Musca the Fly is quite close to the constellation of the Southern Cross, the pattern of stars that appear on the flags of Australia and New Zealand. And hopefully the telescope will manage to find this object, and we can take a picture of it. And as I said, the interface to this telescope is usually a little bit easier than this, but you have to bear in mind that we're controlling an enormous robotic telescope across the internet using quite a lot of complicated technology, and it doesn't take much for one little element to go a little bit wrong, and for us to find it a little bit more difficult to control the telescope. Usually you can just type in names to this interface of the Faulkes Telescope, and it will recognize the object, and it will tell you with a little green tick whether this object is visible in the sky or whether it's not, which would be a little red cross. And I can just make out the telescope moving there. I'm hoping it's just about in the right place now. It doesn't seem to be moving much. So it should flick up any minute now to tell me that the telescope is pointing at Musca. And we can see the telescope time here is showing 11:04. That is universal time, means Greenwich Mean Time. It's an hour earlier than British Summer Time, of course. And around the world, telescopes use universal time, the time of Greenwich Mean Time, the time we have during our winter months. In actual fact, in Australia, it's dark at this time of night. It's actually 10 hours ahead of us. So the time in Australia at the moment will be actually 10 hours ahead of here. It's 10 o'clock at night. In fact, right. Stop clicking. No, it hasn't. To making one final adjustment. This is what takes up quite a lot of the time of the half-hour sessions you can get on Faulkes. We had booked 2 half-hour sessions this morning. The telescope is now pointing at the object we wanted. Fantastic. I'm going to take a picture of it. It should give me a control screen up any minute. The telescope is moving in progress. And I'm going to take a picture in colour, and our exposure for this picture will be, let me see, 30 to 40 seconds. Let's just say 30 seconds. We're quite fortunate tonight that there is no moon visible in the sky in Australia. It's below the horizon, and that is perfect conditions. We saw from the webcam image earlier of the Delta. I can probably flick over to it now. If I scroll down, we The webcam image of the nighttime sky there is fantastic. The seeing is perfect. We can see lots of stars. We can actually see the Milky Way from the camera. So I'm hoping we should get an excellent picture here of the planetary spiral. Now, this is taking a picture of this dying star in space, and it takes a picture in true color. But the camera is actually a very highly sensitive black and white camera. So the way it gets the colour is to actually put a coloured piece of glass or a filter in front of the camera. And I've let the camera take a picture for 30 seconds, and we can see that the estimated total time in the middle here is 247 seconds, which seems a lot longer. Well, that is because it's taking 3 separate pictures of 30 seconds each. A red picture, a green picture, and a blue picture, with the same camera and a different coloured filter or piece of glass in front every time. And from your spectroscopes, you should know that the colours of light are spread out into all the colours of the rainbow. If you point your spectrometer at the sun, you will see that the white-looking sun, light from the sun, spreads out into all the colours of the rainbow: red, green, blue, or red, orange, yellow, green, blue, indigo, and violet. If you follow the little line for the colours of the rainbow. Well, the primary colours of light are red, green, and blue. Not to be confused with mixing paints, which is an entirely different thing, where you've got red, yellow, and blue, or magenta, cyan, and yellow, the same colours. In light, we talk about red, green, and blue, and we're taking 3 images in red, green, and blue and overlaying them to get a fantastic picture of this thing in space. Now, it's telling me now the telescope is taking the second image, which is the green one, for this observation. And it will be taking a picture of a very, very tiny area of sky. If you will hold your index fingers up at arm's length and look at your index finger nail against the ceiling or the sky, wherever you happen to be sat at the moment, that fingernail is about 1 degree of sky or ceiling. If you happen to place all of your fingers, or your 2 index fingers, next to one another and move them around the horizon as you turn around on the spot, you should be able to put 360 of them together as you turn around on the spot, and that's 360 degrees in a circle. Well, the area of sky we're looking at is much, much smaller than that. It's about 5/60, which is 1/12 of a degree. That's a 12th of your fingernail at arm's length is what we're looking at in the sky. That's the picture that's going to come down the line, and will be coming down any second now. And of course, the picture we're expecting to see is of a planetary spiral, or the planetary spiral, which is a planetary nebula, a star very much like our sun. The telescope is processing and downloading your colour image. It will pass up a little window any second now saying, "Would you like to see your image?" Rod, could you just give me a little smile if you can see this window? Great, thanks very much. So as the little blue counter gets to the end, we should hopefully see the image. There we are. Observation is completed. Click OK to see the image. Now I'm very excited about this. I've never seen it before. What are we seeing? There it is. The planetary spiral. Looks a little bit green and yellow. Not much blue in there, but we'll sort that out later.